Okay, now we continue from here. We'll start at this calculation, which is above bubble point pressure. Now, the other calculations we can perform above bubble point pressure. What's RS? Remember, the plot for solution gas-oil ratio looks like this. Once you get to PB, you're plotting RS against P. Above PB, it's horizontal, it doesn't change. And that means RS equals RSB, right? The value at bubble point. And that's what this is telling you. How about below? Well, we have equations for that. And we'll talk about that later when we get here. So that's how we calculate the values of RS below bubble point. This is above bubble point, this is below bubble point. So RS is just a constant value above bubble point. How about oil formation volume factor? We use oil formation volume factor at bubble point, which we got by finding the minimum from the separator test, right, at this stage. So precisely this value. And this is the relative oil volume that we just looked at, that we used right here and at the end of the previous video. So grab that value, multiply it by this BO from separator test, and that's how you get BO. And how does the dimensional analysis work out? BO is volume at reservoir conditions divided by volume at standard conditions, which is stock tank barrels. So that's reservoir volume at PB, right? That's what BOB is a reservoir volume of the oil at bubble point pressure instead of at reservoir pressure. It's at bubble point pressure divided by surface volume. And the relative oil volume is volume at reservoir conditions divided by volume at the bubble point pressure. So this cancels out this and it gives you the unit for your BO. So dimensional analysis checks out okay. How about oil density above bubble point pressure? You need oil density at bubble point pressure. To get oil density at any reservoir pressure greater than bubble point pressure, you need oil density at bubble point pressure, which comes from what? Differential liberation test. I showed you that previously, right? It's precisely here because this is bubble point pressure. So that's where you get it from, and then divided by the same relative oil volume factor. And dimensional analysis checks out okay. Why are we using cubic feet here and reservoir barrels here for the same thing? It doesn't matter, right? It's a ratio of volumes. The conversion factor, which should be 5.6145, cancels out, right? So the same value here shows up here. We're using cubic feet, so we can cancel out cubic feet in the density. So this cancels out this, and you're left with pounds per cubic feet at reservoir pressure, which is the unit for oil density. Again, that's above bubble point pressure. So all the calculations we've looked at here are what you use above bubble point pressure. And they all come, they're using this relative oil volume coming from flash test, right? I can show you those relative oil volumes again. This is your flash, and this is it. Precisely this. That's what we use for rho O. We just saw was rho O divided by the ratio, and the other one for BO was BOB multiplied by the ratio VT over VB from flash. How about RS? It was RSB all right? Because it's just constant above bubble point pressure. That's the summary of all we've done here. How about below bubble point pressure? The data will be coming from where? Differential liberation data. Of course, we will still need data from separator test. But now you see the relative oil volume subscript what? D and dB. Relative oil volume from differential liberation at bubble point pressure. And that's the equation, and dimensional analysis you can double check also checks out, right? This cancels this cancels that. You're left with this per unit this, which is what this is. All right. And for RS, same deal, but you're using the relative gas volume ratios. It's differential liberation at bubble point. Dimensional analysis also works out. This quantity cancels out this quantity, residual barrel, and you're left with SCF per STB, which is what this is. So this is the equation you use for bubble point pressure. So if you have to plot, bubble point for oil formation volume factor against pressure, and PB, let's assume PB is right here. So below PB, this is PB. Stop writing. Below PB, this part comes from where? This equation. Above PB, this part comes from this equation, which is right here, right? For RS, I already said this is constant, right? That's what this is. But below bubble point pressure, it's this equation right here. That's what gives you this part of the curve. And that pretty much summarizes the different properties you can obtain from PVT data. So I cleaned it up so everything is clear again, and that's how we calculate the different parameters we need using data. We're going to use BO, oil formation volume factor at bubble point, and solution gas oil ratio at bubble point from separator test, and we got that from the minimum BOB because that's what maximizes the amount of oil at surface conditions, and that's what gave us this as BOB and this as RSB. Very important. How about flash above bubble point, right? We care about the flash above bubble point, and it gives us this relative volume which we use in those equations for BOB right here and ρB. So I'm just summarizing here, and of course this is constant above bubble point. Above bubble point, we use those two relative volumes corresponding to these two pressures like I explained. Below bubble point, we use data from differential liberation, and it uses 4 relative oil volumes, right, which are summarized here. These are the main 4 relative volumes: 2 for oil, 2 for gas, and these ones will be used to calculate RS. These ones will be used to calculate BO as shown here. And again, this comes from the BO, the RSB comes from separator test. The BOB again comes from separator test. How about ρOB? Where does it come from? It's not from the separator test. ρOB again is from differential liberation data, which I showed right here. This is your ρOB.